You've probably heard of the Big Bang as the event that gave rise to our universe. You might know most cosmologists believe it occurred some 13.8 billion years ago. It's hard to understand that, at the moment of the Big Bang, all of the energy in the universe, some of which would later become galaxies, stars, planets and human beings, was concentrated into a tiny point, smaller than the nucleus of an atom. And it's not just matter that was born in the Big Bang. In the view of modern cosmologists, matter and space and time all began when that microscopic point suddenly expanded violently and exponentially. The universe began with every speck of its energy jammed into a very tiny point. This extremely dense point exploded with unimaginable force, creating matter and propelling it outward to make the billions of galaxies of our vast universe. Astrophysicists called this titanic explosion the Big Bang. Now let's pause a moment, so that we might draw a distinction between the appearance of all that energy in the Big Bang and its sudden expansion. In that sense, the Big Bang was not the event that caused our universe. Rather, it was the event that gave birth to the universe. Why is this distinction important? Well, it's important because, although science has been able to establish a history of the universe right back to when that tiny point suddenly created our entire cosmos, what preceded it, the reason for the tiny point of energy being there in the first place, is unknown, and may forever be unknowable. The Big Bang is the theory we have constructed for how the universe we see around us came to be. It does not attempt to answer the most common question you humans ask about the origin of the cosmos: why? And this question likely cannot be answered, because, by definition, whatever caused the appearance of that tiny point of energy, containing the seeds of everything that would ever be, was not of this universe. Therefore, whatever caused the universe left no evidence of its existence for us to study, no clue as to what it was. It is also likely that, being something completely outside the universe, we would, in any event, be unable to comprehend it. The laws of physics, of motion, of gravity, of electromagnetism, of thermodynamics, simply did not apply at the moment of the universe's birth because they did not yet exist. They certainly cannot describe the presence and origin of that tiny seed. The Big Bang was like no explosion you might witness on Earth today. For instance, a hydrogen bomb explosion, whose center registers approximately 100 million degrees Celsius, moves through the air at about 300 meters per second. In contrast, cosmologists believe the Big Bang flung energy in all directions at the speed of light, 300 million meters per second, a million times faster than the H-bomb, and estimate that the temperature of the entire universe was 1,000 trillion degrees Celsius, at just a tiny fraction of a second after the explosion. Even the cores of the hottest stars in today's universe are much cooler than that. There's another important quality of the Big Bang that makes it unique. While an explosion of a man-made bomb expands through air, the Big Bang did not expand through anything. That's because there was no space to expand through at the beginning of time. Rather, physicists believe the Big Bang created and stretched space itself, expanding the universe. So if the temperature was boiling hot at the explosion, how were the different elements in life itself created? For a brief moment after the Big Bang, the immense heat created conditions unlike any conditions astrophysicists see in the universe today. While planets and stars today are composed of atoms of elements like hydrogen and silicon, scientists believe the universe back then was too hot for anything other than the most fundamental particles, such as quarks and photons. But as the universe quickly expanded, the energy of the Big Bang became more and more diluted in space, causing the universe to cool. Rapid cooling allowed for matter as we know it to form in the universe, although physicists are still trying to figure out exactly how this happened. About 1/10,000th of a second after the Big Bang, protons and neutrons formed, and within a few minutes these particles stuck together to form atomic nuclei, mostly hydrogen and helium. Hundreds of thousands of years later, electrons stuck to the nuclei to make complete atoms. About a billion years after the Big Bang, gravity caused these atoms to gather in huge clouds of gas, forming collections of stars known as galaxies. Gravity is the force that pulls any objects with mass towards one another. Where do planets like Earth come from? Over billions of years, stars cook hydrogen and helium atoms in their hot cores to make heavier elements like carbon and oxygen. Large stars explode over time, blasting these elements into space. This matter then condenses into the stars, planets, and satellites that make up solar systems like our own. How do we know the Big Bang happened? Astrophysicists have uncovered a great deal of compelling evidence over the past 100 years to support the Big Bang theory. Among this evidence is the observation that the universe is expanding. By looking at light emitted by distant galaxies, scientists have found that these galaxies are rapidly moving away from our galaxy, the Milky Way. An explosion like the Big Bang, which sent matter flying outward from a point, explains this observation. Scientists have also been able to uphold the Big Bang theory by measuring the relative amounts of different elements in the universe. They've found that the universe contains about 74% hydrogen and 26% helium by mass, the two lightest elements. All the other heavier elements, including elements common on Earth, such as carbon and oxygen, make up just a tiny trace of all matter. So how does this prove anything about the Big Bang? Scientists have shown, using theoretical calculations, that these abundances could only have been made in a universe that began in a very hot, dense state, and then quickly cooled and expanded. This is exactly the kind of universe that the Big Bang theory predicts.